One of the important features that was introduced with 802.11n was something called Mimo, M-I-M-O, which stands for multi-in, multi-out. And then later on with AC, something called MuMimo, which is multi-user MIMO. Mimo introduced multiple antennas. That's the simple version of it. They perform a number of functions in the regular Mimo version of this. Let's take a look at those functions. First is something called Multipath. Now, Multipath is what happens when here's a transmitter and it's transmitting a signal over here to receiver 1, and it doesn't just follow a straight line. These radio signals go out in every direction. So here it's hitting the ceiling and hitting transmitter or receiver number 1. Here it's hitting some other obstacle, a wall or a kitchenette or something, and then hitting the transmitter. And the problem is that these signals, because they're traveling farther, are slowed, and so it's not receiving all of the signals at the same exact time. They're set apart from each other. So what Mimo can do by having multiple antennas, it can intercept these differently, just like your ears can make out where something is because the sound arrives at one ear earlier than it arrives at the other ear. Or your eyes can make out the depth of something because light arrives at different times from one, or at a different angle from one as the other. The same thing's going on here with Mimo. These multiple antennas can put that information together and get a better picture, and in fact, these things can add to each other to get even faster data rates. And so that's what Mimo is doing, is compensating for this multipath problem. Another thing it can do is something called beam forming. Because you've got multiple antennas, you now have this strange capability to be able to direct the beam going to different devices directly to those devices rather than off where there are no devices. So it can sense where these devices are because of incoming information, and it can form these beams to give a stronger signal to each individual device. The third one is channel bonding. So normally we have several channels like this. This is a 2.4 gigahertz, and you can see we're ranging from 2401 to 2473 gigahertz here into several sub-channels. Well, each sub-channel can carry information. We've looked at FHSS and DSSS where we use multiple sub-channels, but one thing that Mimo can do is combine multiple sub-channels into a single channel to give it greater bandwidth per channel. And if it's not using all of these, then it might as well combine them and get greater capacity per smaller or per less number of channels per channel that way. So those are the three things that Mimo gives us. Now let's take a look at the 802.11ac additions to that, something called MuMimo, or multi-user MIMO. So in this case, we have multiple antennas. Well, one thing that happened is we increased the number of antennas up to 8. And so now you see these sort of octopus types of Wi-Fi routers. They're looking weirder and weirder as we go along. And who knows, we might look back at these in 10 years and laugh at them because they were so ugly and weird. But they're by today's standards, excellent. But now we have detached these antennas and given them capabilities to work independently. So I can have one antenna servicing this screen over here, another one servicing this one over here, and so on. And they can be in various modes. So I can have each one independent. I can have, if I don't have that many devices here, I can combine 2 of them. I can combine 4 of them, and use some of these other capabilities that we have with regular Mimo for each one. So then I can really boost my speeds out of this thing. So MuMimo then detaches these antennas from each other as needed in order to serve more, either serve more data This could be sending one frame and then this one another frame and then this one another frame, or to send different directions.